Hi Dora, I got your message on the help board and here I come to help. I'm going to use a video. I think it'll help you more if I do a video rather than just put the steps down. Okay, here's your example 3 from the book. It's 4 square root of 3 times the quantity 2 square root of 3 minus square root of 6. Anytime there's parentheses, we want to get rid of the parentheses by using the distributive property. So we're going to take the number outside of the parentheses times the first number, and then the number outside the parentheses times the second number. When you're multiplying radicals, you always multiply the numbers outside the radicals together, and then you multiply the radicals together by multiplying what's underneath the radicals together. Now, if you're taking a radical times itself, square root of 3 times the square root of 3, that's going to be the same thing as the square root of 9, right? Because you're going to multiply what's underneath the radicals together and you get the square root of 9, and that would just equal 3. Anytime you multiply a radical times itself, you just get the number under a radical. Or if you had something like this, the square root of 3 squared, it's just going to be the number under the radical. So keep that in mind when we do these problems. So you're going to multiply this times the first number inside the parentheses. So we multiply the number part in front of the radicals first, and we get 8. And here's our example. We get the square root of 3 times the square root of 3, and that's just going to, instead of 3 to 3, it's just going to be 3. Now we take 4 square root of 3 times the second one. So we get 4 square root of, and you multiply what's underneath the radicals together, and you get 18. Now the book does it a funny way. We do it in our head. It's just easier to do it in your head. Now, you'll notice you have the square root of 18 and you might be tempted to quit. That would be like having 2 over 4 and saying, oops, I got the answer. But you know you need to simplify it to get 1/2. This is the same thing. This radical is not simplified, and the way you can tell is you would ask yourself after you multiply, or whenever you see a radical, you say, is there a perfect square that will divide evenly into this number? So you need to know your perfect squares are just 2 times 2, 3 times 3, 4 times 4, 5 times 5, etc. So I'll just put a few out here. I'm not going to need them very high for these problems. So what you say is there a perfect square from this list that divides evenly into 18? And, well, let's just get this one down first. So we get 24 minus 4, and looking down here, which of these numbers goes into 18 evenly? Well, duh, it's that one, right? So this is going to be split into 9, and then what's left is 2, because 9 times 2 equals 18. So we're just going to split our radicals the same way. We can split them up, we can multiply them together to get a number, and we can also split them up to get 2 separate radicals. But we're going to split them up differently than they were put together. So you put your perfect square one first that you found over here, and then what's left is over here. So we just keep simplifying. We get 24. The square root of 9 is just 3. And one more step, 24 minus 12 square root of 2. They did it look totally different the way they did it in the book, but they're basically doing the same thing. So I thought we'd try number 11, since example 10 in your book is exactly the same as this example. The problem 10 from the problem set is exactly the same as this example. So I'm going to have to do one that you have for homework. So let's try this. We're going to take this number times the first one, and this number times the second one. Multiply the number outside of the radicals together, and you multiply what's under the radical together, which would be the square root of 25, and that's just 5. Anytime you multiply a radical by itself, you just get the number under the radical. Then we take 5 times 3, and we get 15. Square root of 5 times the square root of 10 is the square root of 50. Now this isn't simplified yet, so we get 50 minus, make sure I did that right, 15, and we look on our list and see which perfect square divides evenly into 50, and you can see it's 25. So this would split into 25 times 2. So we put them under their own radicals, 25 and 2, and then we simplify this radical. So we get 50 minus 15 times 5, because the square root of 25 is 5, square root of 2. And finally you get 50 minus 75 square root of 2. And hopefully you'll get the hang of those soon. These radicals can be tricky at first. So that's it. If you have any other questions, don't hesitate to put something in the help board.